Hi class, let's take a look at this problem here. We have a simple random sample that has been selected from a normally distributed population. We're going to test a given claim. We want to identify the null and alternative hypothesis, the test statistic, the critical values, and state the conclusion. So we have a simple random sample of pages from a dictionary is obtained. Listed below are the number of words defined on those pages. Given that this dictionary has 1,459 pages with defined words. The claim is that more than 70,000 defined words is the same as the claim is that there are more than 70,000 defined words is the same as the claim that the mean number of defined words on the page is greater than 48. So in other words, this is the claim right here, greater than 48. Okay? So because it says greater than, that means one tail. And specifically greater than 48 is going to be the alternative statement. Alpha is 0.05, and we want to basically test the claim. So here is our data. So let's go ahead and open this data in Excel. So here it is right here. So I'm going to go ahead and copy this data directly into StatCrunch. And there it is right there. Okay. The null and alternative statements have already been defined, so let's go ahead and find the test statistic. So this is going to be a test stat, and you'll notice that we only have 10 samples. We are not given any population information about this data, so therefore we're going to use the t-stat, one sample with data. The data is in var1, and the null is 48, and the alternative is greater than. And now we need to find the test statistic. So let's scroll down here and hit compute. And here's my test statistic right here. Note that this is a t-stat. Okay, why? Because even though there is normality, there is no population parameters provided, no population standard deviation specifically. Okay. Second, the sample size is less than 30. So under those conditions, I'm going to have to use the t-stat as opposed to the z-stat. Okay, remember that my first gate is, do I know the population standard deviation? If the answer is yes, I use the z as in zebra. If the answer is no, I have a second question. What is the sample size? If the sample size is bigger than 30, I use the z as in zebra. And if not, my only choice is to use the t or to not attempt the problem. Okay, so there is the test stat right there. Notice the p-value is 0.063. We're probably going to need that later. Now they want me to find the critical values. Well, they tell me the alpha is 0.05, and we know it's a one-tail test. So let's go back to StatCrunch, go to Stat, Calculators, and t-distribution now, okay, because we've already established that this is going to be a t-type test. There are 10 data points, so that means the degrees of freedom is 9. We want greater than, and specifically we want greater than 0.05, and that gives us a critical value of 1.83. So 1.833 to 3 decimal places. So what is the final conclusion? Okay, well, as you can see here, this critical value here, okay, is smaller than the test statistic. Or another way of looking at it is that the test statistic is not between the 0 value and the critical value. So the 0 value is at the peak. So this test statistic is somewhere within this tail out here someplace, 3.106. So therefore, we are going to reject the null. There is sufficient evidence to support the claim that the mean number of words is greater than 48. Do the results suggest that there are more than 70,000 defined words in the dictionary? Well, I would say that it would, because we established in the problem that more than 70,000 defined words is the same as the claim as the mean number of defined words on a page is greater than 48. So we've already established a correlation between these two things. So therefore, I would say that there is sufficient evidence to support the claim. Thank you.